Alright, how I Woodward Product Manual 36703 Revision New Original Instructions PGEV and PGE Locomotive Governors. Chapter 3 Principles of Operation Introduction. For the purposes of this description, the PGE and the PGEV governors are considered to be consistent of three major functional sections: the basic governor section, a speed setting section, a load control section. A basic governor section consists of oil pump with the two accumulators, speeder spring, flyweight headily assembled thrust bearing, pilot valve, plunger, eroding bushing, buffer compensation system, a power cylinder, the governor drive shaft through the governor basin, engaged with the rotor getting bushing. The pump supplies the pressure oil for the operation basic governor section, the speed setting section, the load control system except for the application of using the remote vane servo when the engine is supplied with the control system and all other auxiliary features of this device. A spring-loaded accumulator relief valve system maintains governor oil with operating the pressure while operating pressure is reached with a single spring pressure is overcome. The oil is released to the sump. Direction of rotation is normally determined with by the engine manufacturer or the Woodward governing company. The governor rotation is easily fixed to CW or fixed C, clockwise or counterclockwise or reversible. Should the arrangement be reversible rotation, four check valves and the oil pump passages for fixed rotation, four check valves are removed and two plugs are placed in the two passages, allowing only the one of the direction flow. Alright, important. Governors for locomotives are built for one direction of rotation. The governor drive rotates for the oil pump pilot valve bushing the flyweight head. Assembly is driven with the rotating pilot valve bushing. The thrust bearing rides on the top of the flyweight head of the toes, permitting with the rotational manner between the downward force of the speed spring and the upward force of the flyweight. The relative motion between the bushing and plunger minimizes the static friction. Several types of the flyweight head assembly is available. The exact style depends upon the engine driving with the train. With the governor, a solid head is used whether the drive is relatively torsional vibration, spring-driven oil pump, oil-damped head assembly are used with the attenuated objectional torsional vibration, which is imparted to the governor from the engine. The vibrations may originate from the source other than the driving itself, but reach for the governors with a drive connection. Unless minimized with the eliminated, these vibrations are sensed with speed change, and the governor will continually adjust fuel rack in an attempt to maintaining the constant speed. Alright, the greater the two opposing forces moves, the pilot valve plunger up and down with the flyweight tends to lift the plunger, while speed or spring force of the tends to lower the plunger. When the engine is on speed, any of the speed setting with the force of the balance with the flyweights assume the vertical position, and the position of the control lane of the pilot valve plunger is centered over the regulating valves and the rotating bushing. No oil other than leakage makeup flows from the buffer compensation system of the power cylinder. Change in either of these two forces will move the plunger into the center position. The plunger will be lowered when the governor speed setting is unchanged for the additional load, slowing the engine and the governor, thereby decreasing the flyweight force. 2. The engine spread is unchanged with the speed or spring force is increased with the raise of the governor speed setting. The similar pilot valve plunger will be raised. 1. When the governor speed setting is changed by the load removed from the engine, causing the increase for the engine governor speed, hence there's an increased flyweight force. 2. When the engine speed is unchanged with the speed spring with the force of the reduced from the low of the governor speed setting, the plunger is lowered in under speed condition. Flow pressure oil is directed for the buffer compensation power cylinders to raise the power piston, increase fuel when lifted, and overspeed condition oil permitted with the drain. These are area of sump and the power position moves downward to decrease fuel. The buffer position and springs need valve with the hydraulic circuit between the pilot valve plunger of the power cylinder make up with the power compensation system. The system functions with the stabilizer of the governing act with the minimize over undershoot following the change of the governing speed with the setting of the change in load on the engine. Establishes temporary negative feedback with the temporary droop in the form of the pressure differential with applied across the compensation land of the pilot valve plunger. The flow of the oil into and out of the buffer system displaced with the buffer system in the direction of flow. The movement increases increases the loading with one spring when decreasing the load on the other, and creates a slightly difference in the pressure on either side of the piston with a high pressure on the side opposite with the spring being compressed. These pressures are transmitted to the opposite side of the plunger compensation land and produce a new net force upward and downward, which assists the recentering of the plunger when a fuel correction is made. Alright, your speed setting and load increase. Increasing the speed setting and increasing the load on the engine of the given speed, with the setting having identical effect. In either case, the flyweights move an inward or upward speed downward and increase the speed spring forces on to decrease the central force, causing the decrease in engine speed as the load is added. The movement of the flyweights is translated into the downward movement of the pilot valve plunger. The director of the pressure of the oil to the buffer system causes the buffer piston to move toward the power cylinder. The oil displaces the movement of the buffer piston, forces the piston, power piston to upward into the increased fuel direction. The oil pressure on either side of the buffer system piston simultaneously transmitted to the plunger compensation land with the higher pressure on the lower side. The net upward force has produced an adding of the flyweight force and assisting the restoring and balancing force recentering of the pilot valve plunger. And the effect that enables the governor to cut out the additional fuel need for the acceleration, stopping the power piston when they reach the point of the consideration amount of fuel required for the steady-state operation of the new high speed and loaded. The engine continues to accelerate toward the set of speed compensation forces gradually dissipated with the offset. The continuing increase of flyweight force is done equalizing the pressure on each side of the compensation through the needle valve with the rate proportional to the continued rated acceleration of the rate of disposition, but the same as the rate of the increased flyweight force. As pressure differential to reduce zero, the instant flywheel force between becomes exactly equal to speed or spring force. This minimizes the speed overshoot of the permits of the governor to quickly re-establish stable operation. The needle valve setting will determine the rates at which the different pressure dissipated allows the governor to be matched to the characteristics of the engine. The compromise of the buffer spring returns the buffer piston to the center piston at the pressure differential dissipated. Whenever large changes in speed setting or load are made, the buffer piston will move far enough to uncover the bypass port with the buffer cylinder. This limits the pressure differential across the buffer system, permits the oil to flow directly to the power cylinder. The power piston is made to respond to quickly large changes in the speed setting of the loading. Alright, your speed setting and load decrease. Decreasing the speed setting and load of the engine of the given speed setting is identical to the effect of causing the reverse action that described above. The flyweights will move outward and lifting the pilot valve with the plunger, allowing the oil to drain with the buffer compensation. The buffer piston moves all the way from the power cylinder, permitting the oil to drain from the area under the power piston that moves downward into the decrease the fuel direction. The different pressure action across the compensation land produce a net downward force, assisting the speed spring and recentering the pilot valve and plunger slightly before the engine is fully decelerated. The steps of the power piston movement, the reach end point corresponding with the amount of fuel required for the steady-state operation, no lower speed load, deception of the compensating force with the same manner previously described, and minimize the speed undershoot. Alright, your compensation cutoff. When large decrease in speed load of the power piston moves to no fuel position, blocked for the compensation oil passage between the power cylinder and the needle valve to prevent normal equalization of the compensation pressure. This holds the buffer piston off the center and increases the level of the pressure transmitted to the upper side of the plunger compensation lamp. The increase in pressure differential, adding the effect of the speeder spring temporarily increases the governor's speed setting. The governor was thus beginning the corrective action soon as the engine speed drops below the temporary speed setting, and the starting of the power piston used upward restore the fuel supply system sufficient time to prevent large underspeed transition above the action, sometimes referred to as compensation cutoff. The upward movement of the power piston again uncover the compensation oil passage. Normal compensation act will resume the stabilized engine speed at actual speed setting of the governor. Alright, important. Due to the location of the compensation cutoff port of the power cylinder wall, the governor and the fuel rack linkage must be adjusted so that the power piston gap does not exceed 1 1/32 of an inch at idle no load. Speed setting section. The section consists of speed setting cylinder, speed setting pilot valve with the plunger, housed in the rotating bush, 4 speed setting solenoid, a triangular plate, and a restoring linkage mechanism. General, the speed setting provides with the method of changing the compression with the force with the spread spring with the output of the flyweight, central force, It does not control the piston with the speed setting piston. The speed setting with the cylinder. The control is admitted with the cylinder. The piston moves the downward, compromising the speeder spring, raising the speed setting with which is allowed with the drain with the cylinder with the piston speed spring forcing the piston upward, reducing the spring force, lowering the speed setting. The following out oil into and out of the speed setting cylinder regulated with the speed setting. Pilot with the plunger review. Rotating bushing the plunger is controlled with the solenoids provided with the incremental control of the speed of the equally spaced steps. An internal gear of the governor flyweight head drives the bushing through the splaned mating gear on the lower end of the bushing. The rate of the maximum, the speed of the setting with the piston over the full downward stroke is idle to the maximum, usually retarded to occur overcome some specific time. The internal interval minimize exhaust smoke during the acceleration. This is done by adding a governor pressure oil to the rotating bushing through an orifice which registers the main supply port once for every revolution in the bushing. This retards the rate at which the oil is supplied to control the port of the bushing and thus the oil flow to the speed of the setting cylinder. The diameter orifice specific time interval which may be anywhere with a nominal range from 1 to 30 seconds. Typical engine acceleration period. Switching the suburban service is approximately 5 seconds. For freighter passenger service, probably 15 to 30 seconds. For turbo supercharged engines, the timing may be approximately 50 seconds to permit the supercharger to accelerate to the engine. On turbocharged units, the rate of the movement of the speed setting piston with the fully upward stroke of the maximum to the idle speed is retarded to prevent the compressor surge during the deceleration. The time to be anywhere within the normal range, 1 to 15 seconds. In case vertical slide with the drain load. Land of the pilot valve flanger resist for the second orifice the rotating bushing with once the evaluation that retards at the rate at which the oil allowed to drain from the speed setting cylinder. Alright, speed setting, there are 3 of 4 speed setting solenoids, A, B, and C, actuate the pilot valve plunger to control the movement of the triangular plate. The rest of the top of the floating attached with the plunger of the 4 solenoid D controls the piston and rotating bushing in respect of the plunger, energizing A, B, and C solenoids singly. Various combinations depressed with the triangular plate put in to determine the distance for each for the combination of the downward movement of the plate is transmitted through the float lever on the uncenter of the plunger. This directs intermittent oil pressure to the speed setting cylinder, forcing the speed of the setting of the piston downward to increase the governor speed setting, energizing the D solenoid, pushing the rotating the bushing downward, opening the control port to the draining oil from the speed setting cylinder, thus decreasing the speed setting, and identifying the letter will be found with the solenoid bracket adjacent to the solenoid. Figure 3.2 is an additional aid with the understanding that the various governor components of the oil patch is simplified with the color coded with the ease of the following oil flow through the system. The lower half of the governor functions to maintain the constant engine speed, controlling flow of the engine cylinder. The upper half of the governor consists of the column and cover the internal related parts for the change in governor speed setting, the control valve with the load regulator shutting down the protective devices. Advance and retarding the throttle control from one step to the next, energizing and de-energizing the solenoids is various combination to increasing or decreasing engine speeds approximately equal to the increments. Whenever the changing of the speed setting is made with the movement of the speed setting piston downward or upward, it is transmitted feedback through the restoring linkage floating lever to the recenter of the pilot valve plunger. This stops the flow of the oil into or out of the speed setting cylinder of the position corresponding to the speed setting. Speed setting increases. One or more of the solenoids is energized, de-energized by the moving the throttle. In the higher step of the solenoid plungers move downward and depress the triangular plate and turn of the floating of the lever. Since the right end of the lever is attached to the lower end of the restoring link, the left end of the lever is forced downward to uncenter of the pilot valve plunger. The directs immediate with the pressure oil to the speed setting of the cylinder increases, which forces the piston downward, further compresses the speeder spring, thereby increasing the speed setting. The downward movement of the piston is transmitted through the restoring linkage for the right end of the floating of the lever, causing it to move downward the proportional amount that allows the load spring with the under the pilot valve of the plunger to raise the plunger. Flotation lever pivoting the triangular plate with this action will continue. The plunger is again recentered and stopping the oil from the speed centering cylinder in the instant piston reach of the new lower piston corresponding with the increased speed setting. Alright, this shows you the figure of the 3-1 schematic drawing of the typical PGE governor. Okay, starting from the top, you have From the left over here, you have the speed setting, valve, plunger, control land, slider, oil, drain land, governor, sump, intern, drain, pour, oil, bushing, rotating, intermediate supply port, triangular plate, speed setting, floating lever, restoring link, base speed metering nut, restoring lever, shutdown rod, shutting nuts, linkage, speed setting indicator, piston stop, speed setting piston, speed setting cylinder, speed setting servo pin, speed setter spring cylinder and thrust bearing, flyweight head and bushing, compensation land, pilot volt plunger, control land, governor sump, drive shaft. Over here you have an accumulator, governor sump, and relief port, oil pump, bypass port, buffer, piston, compensation needle valve, excitation for the and timing valves, governor sump, and then over here in the corner we have a ground the valve plunger, governor sump, load control supply valve, integral vane servo, eccentric level adjustment, hanging hinge, range adjustment screw, load control floating lever, torque, load control position of the indicator, power piston travel gap indicator, overriding piston load control pin, pilot valve plunger. And these over here show the different shades: sump oil pressure, tamper oil governor, power cylinder oil pressure governor, intermittent and oil pressure, and governor pump oil pressure. Alright, speed setting decrease. Making the throttle of the lower step of de-energize or energize with one or more of the solenoids caught with the reverse action of the speed setting increase. The end triangular plate will move the upward, being held in the contact with the solid plunger for the loading of the spring. This allows the load spring under the pilot valve with the plunger to uncenter. Raise the plunger with all the valves to drain with the speed setting with the cylinder. The upward movement of the speed setting piston is transmitted through the restoring link of the recenter plunger. Normal shutdown. Under normal operating conditions, the engine shutdown is moving through the stop position. The engineer dies the D solenoid, pushing with the rotating of the bushing down on opening the control point of the drain oil from the speed setting of the cylinder. The speed setting of the piston then moves up, lifting the shutdown nuts and shutting the rod into the process. This lifts the governor pilot valve plunger and drain oil from the buffer compensation system, allowing the power piston to move down to shut down the no fuel position. The upward movement of the speeding system is limited to the stop screw. The speed setting piston screw limits the piston rod travel to restarting the engine because of the less oil is required to move the speed setting piston down. Or your load control section, figure 3.1. In most governor applications, primary function for the governor automatically maintains specific engine speed under the varying load of the condition control, but the fuel flowing through the engine and locomotive of the governor's secondary function include the maintaining the constant power of the output for each of the specified speed settings with each of the throttle setting. There is both constant engine speed, predetermined fixed rate of the fuel flow required. The safety of the both condition, the load of the engine must be adjusted with the locomotive with operating condition. Speed locomotive auxiliaries vary with the function with the load control to do this. Important: maintaining the constant engine speed does not mean the locomotive road speed will be also constant. Control of the engine load is achieved with the regulating engine speed of the fuel setting of the done with the adjusting generator with the field's excitation control through the use of the variable servo control variable resistance general field circuit. The variable control with the load control pilot and related linkage in the governor of the load control packet linkage is arranged so that each speed setting of there is only the fuel setting of the engine power output, which is the load control pilot valve plunger, will be centered. An increase and the decrease of the engine governor speed setting of the engine load will change fuel flow. The power piston moving either to increase the decrease fuel direction will be through the float being lever linkage move the load control pilot valve under up or down respectively. The vane servo decreases the increase of the fuel excitation in turn engine load. Alright, stop. This is your section of the diagram of the PGE governor. This shade shows the governing pumping oil pressure, governing intermittent oil pressure, trapped oil, and governor power pressure, cylinder oil pressure, governor pump isolation. Alright, and starting at the top, you see the switch rod nuts going to the clockwise cover, the oil filter cap, load control linkage, speed settings, cylinder and piston, load control pilot valve, speeder spring, flyweights, power spring, pilot valve bushing, power piston, pilot valve plunger, compensation load on pilot valve, buffer spring, control land, maximum fuel, minimum fuel, compensation needle valve base, drive shaft, accumulator, summer pistons, accumulator springs, regulating port, buffer springs, buffer cylinder plug, power case column, speed setting pilot valve, triangular plate, electrical connector, speed sections, setting solenoids A, B, and C and D, and base setting speed and shutdown rods and nuts. Alright, in some cases, applications, the vano servo is remotely unilaterally controlled by the governor through the tubing using the oil for the governor engine lubrication system of the operation of the vane servo may either be the rotator or the rotary or piston type. In the other application with the vano servo is integral with the governor using the governor oil for its operation. The integral oil unit with the unit of the communicator about which the set of the movable brush rotating with the change of the valve of the resistance and the generator field excitation circuit of the brush is derived with the servo motive with its turn control the load control pilot valve with the remote. The units are usually provided with the locomotive manufacturer in different sizes of the construction with the integral unit. However, the method of control and operation is easily identical. Is essentially identical. The load control pilot valve with the supersend with the load control floating with the lever, the lever is connected with the power piston tail rod at one end of the speed setting of the piston on the other end of the movement of either the bolt of the piston causing the corresponding movement of the plunger, which is housed with the non-rotating bushes. Pressure oil supplied with the plunger external from the engine lubrication system intake over the governor oil pump two lanes with the plunger control flow from the oil to the vane servo with the internal governor was also operated with the vano servo supply cutoff valve with the provided with the oil passage to bad load control valve with the supply valve with the closed with during the starting with the available with the oil governor oil pump with the delivered speed setting of the power piston quickly opening fuel injectors minimize the cranking time the engine starts with increasing the governor oil pressure opens the supply valve and the restores normally load control system operation. The valves are served the secondary system controlling the vane servo rating and the timing. Or your operations, assuming the train in the motion with electrical load with the balance and desired engine flow with the engine fuel power output existing the governing speed setting of the load control system will be stationary with the pilot valve of the plunger centered when the compressor turns on for any situation occurs with the increased load, electrical load, and the generator increase the transmitted with the engine speed decrease with the governor increase the fuel flow to bring the engine back to the preset speed while this carrying the added load. The power piston moves upward and simultaneously raising the right end of the load of the control of the floating lever in which the turn of the pilot valve of the plunger above this or direct pressure of the oil pressure upper control port and the bushing decrease the excitation side of the vano spirit opening of the low port with the bushing to the drain reduction line engine over speed with the governor will act as and reduce the reduction of the field excitation current with the engine fuel will continue the power piston floating of the lever return to the original position the recenter of the pilot valve of the plunger stop of the servo meter with the constantly electrical load reduces sufficient again to rebalance the required engine power to output the fuel flow. At this point, the engine will have also returned on to an on-speed condition. Operation load decrease. Under the same conditions stated above, the decrease of the electrical load will reduce the engine load, causing the engine to decrease fuel and process lower the right of the end of the floating lever to move the pilot valve with the plunger below the center, decreases the pressure of the oil from the low control valve control port, but the pushing for the increasing excitation side of the vano servo will increase the load, but the engine will underspeed, but the governor will act with the increased fuel, the increase the field excitation current, but the engine's fuel will continue until the power piston floating lever will return to the original position, recenter of the pilot valve with the plunger goes stop, the governor consequently electrical load is spread insufficient to again balance the engine power output with the engine oil engine on speed. Alright, operation with speed setting increase advancing the throttle with a higher step at the causing the pistons downward lower to the left end with the load controlling float lever displaces the load control pilot valve with the plunger below the center of the pressure oil is directed with the increasing excitation side of the vano servo the governor acts to increase the compensation with both increase the speed setting of the simultaneously increase the electrical load. If the power piston moves upward, it raises the right end with the floating lever the return with the pilot valve with the plunger to center position. The stop of the servo meter of the power piston reaches the higher piston position corresponding with the increased speed setting. At this point, the electrical load has been significantly increased to balance the increase of the engine power output. Alright, your operation speed setting is decreasing. Moving the throttle lower speed, with causing the speed setting piston to move upward the raise for the left of the end of the load control floating lever lifts the power pilot valve of the plunger above the center of the piston. Pressure oil decreased with the decreased excitation side of the vano servo. The governor acts to decrease the fuel compensation both with decreasing speed setting and simultaneously decreasing electrical load. The power piston moves downward and lowers the right end of the floating lever to the return of the pilot valve of the plunger center of the position. They stop at the servo motor of the power piston and reaches its newer lower corresponding decreasing speed setting. At this point of the electrical load has sufficiently decreased the balancing decrease for the engine power load output. Alright, your load control balancing of the rate of the vano servo meter or the timing may be controlled with the effectively controlled rate of load of application provided with the stability overall system. Several methods are commonly used to provide balance and or identical to restrict the flow of the oil with the vano servo to determine the rate of the movement. Some governors the oil flow is restricted with the number of the size and position of the group of the orifice holes restricted ported with the load control bushings which are open and closed moving in the pilot valve with the plunger with the arrangement of progressively increasing or decreasing the rate of movement that occurs depending on the degree of the movement of the plunger. This rate will not necessarily be the same in both directions. Governors used with the remote servos may have the separate timing valve assembly consisting of two adjustable ball check valves with a series of common housing. The assembly may be externally mounted on the governor remotely located with the connected with the lines between the governor and a servo. The valves are individually adjusted with provided with a decreased maximum rate movement over the fuel over the travel. The servo meter increase with the decreased excitation. Governors will integrate the vane with the servo may be used similar arrangement of the timing valve assembly, except that the ball valves are individually housed and internally installed with the top of the governor column. Alright, your minimum and maximum field start adjustment. The load control system of the government may set up either a minimum or maximum field start. A minimum field start builds up the engine load speed provided with a smooth takeoff with the slack of the train. The load control pilot the valve the mechanically set above the center with the throttle in idle position. The field excitation retarded to the retarded position to the pilot valve plunger. The vane servo rheostat the remains of the maximum excitation position until the throttle is moved with increased speed the direction lower load of the control pilot valve with the recenter position beyond the increasing excitation. Maximum field start. Enable the engine to build up immediately for the rapid acceleration. Load control pilot valve with the mechanically set below the throttle of the idle position. Field excitation is advanced to the advanced position of the pilot valve plunger. Vane servo rheostat means the maximum excitation position until the throttle is moved into the increased speed direction of the raised load of the control pilot valve. Load control override optional. Under certain conditions, the locomotive operation transition maximum field start and wheel slip is sometimes desirable and necessary to override the normal action of the governor load control mechanism cause the reduction generated excitation current. It would normally respond to increasing excitation current. Load control's overriding maximum of the governor consists of the overriding solenoid or ORS. To position overriding control with the overriding piston with the cylinder surrounds with the upper end of the load control pilot valve plunger. See figure 3.1. Energizing the overriding piston solenoid pushes the overriding valve plunger down with the closing the down of the sump, allowing the pressure of the oil to flow with the overriding cylinder. The overriding piston moves upward with contacting the spring of the collar of the stem of the pilot valve plunger, lifting the plunger above the center position of the slot and the link connection of the pilot valve plunger. The floating lever permits the plunger to independently of the lever. This direct pressure for the decrease in the excitation side of the Verno speeder. Vane servo, the reducing the generator with the override solenoid is de-energized with the overriding valve. The plunger moves upward and closing the pressure port, allowing the oil to drain from the override cylinder. This restores the normal load control system operation. Or your transition, a condition where the electrical circuits between the generator and the traction motor automatically change with the overrated road speed changes to provide more efficient transmission electrical power. Overriding is used in circumstances to project switching gear from the arcing, which would occur during the transition from the high current existed with the traction motor circuits. Modified maximum field start. Variation used in some application where the load control mechanism arranged with the maximum field start, but desirable to hold the vane servo rheostat minimum excitation position at idle speed. Normal operation is mixed is restored with the throttle advance with the first step of allowing the vane servo to increase the excitation toward the maximum of the train slip. starts. Wheel slip. When real and load conditions cover the drive, wheel slip immediately with the decrease of load occurs with the traction motor in the generator. The resulting increase in the engine speed would normally cover the load control system to respond to increase the generator output at the time whenever there is no demand. The overriding is used in the circumstance in conjunction with the wheel slip relay. If the locomotive is so equipped to cause the reduction of the generator output until the wheel is slipped and cease, operating the output overriding solenoid is done through the automatic switching devices. Alright, fast unloading. Maybe used in conjunction with load control overload mechanism to provide with the quick unloading with an integral vane servo. The fast unloading cannot be used with the remote servo application with the external timing valve with the two methods available. One, the lower end of the load control pilot valve with the plunger has additional land. The additional port of the bushing passes the restricted port of the bushing. When the override solenoid energizes the plunger of the control upward related with the extra port of the fast unloading with a vane servo. 2. The plunger has an additional land over the lower end. Instead of the bypass of the plunger is a small orifice holes in one side of the bushing. The radial slot is located with the bushing midway between the orifice holes at the overriding solenoid to energize the plunger up center of the upward release of oil through the orifice holes first in the large displacement pilot valve taking place. Oil is released through the servo, both the orifice holes and radial slot. Both methods allow the vane servo to move rapidly in the direction of movement excitation. Integral vane servo assembly optional. Integral vane servo is used with low wattage pilot amplifier type excitation systems. In conjunction with the load of the control mechanism, the governor automatically regulates the generated output, thereby maintaining the constant engine power output of each of the throttle. The vane servo, each of the resistors pack of the ceramic resistor of the pack. Figure 3.3a shows a vane servo act with the resist pack of the vane servo ceramic resistor appears in figure 3.3b. Both servos have the vane type of the rotor servo meter drain. Oil collects for the cover of both units. Cool the resistor packs out of the ceramic resistor. The commutator resistor pack of the ceramic resistors are electrically from the vane servo unit. The vane servo shaft output has external serrations, which with one missing tooth, the slot formed with the missing tooth males and rigid with both drive the shaft to make sure that the two shafts assemble correctly. Important contact woodward at the details accumulating limits. Wherever the load control pilot valve of the governor column is upper and center with the pressure oil directed to one or the other side of the vane servo, which is the opposite side of the end of the drain. The cause of the vane rotate with the term the rotating the contact brush assembly with the communicator. The position brush for the communicator segment to determine the circuit resistance and thereby generator field excitation current. Figure 3.3a shows an integral vane servo with the resistor pack assembly, the vane servo motor. Your contact brushing and the indicator is the communicator. The terminal leads the governor side plate and the resistor pack. Alright, and figure 3B is integral vane servo with a ceramic resistor vane servo emitter beam spring plate, ceramic resistor terminal board wires, and governing side plate. Alright, lube oil pressure shutdown and alarm. Engine oil pressure detected with the oil pressure diaphragm. The shutdown of the valve plunger with the connection with the diaphragm, which has the 3/4 of the acting upon it, the load with the spring. The engine oil pressure, the act on to the move to the right. The generator speed with the setting with the servo oil acts to move to the left. Normally the load spring and the engine oil pressure for the diaphragm shutdown with the valve plunger to the right and permitting the oil left down. The shutdown with the piston with the drain sump. The engine load up the lube oil pressure below the safe and the speed setting. Servo oil pressure, which is dependent on the speed setting on the rate of the speed setting. Servo overcomes the load spring and engine oil pressure force to the move of the diaphragm shutdown with the valve plunger. The governor pressures oil directing around the shutdown plunger with the shutdown piston move to the right. The shutdown piston move to the inner spring of the shutdown plunger with the differential position is then allows the high engine lube oil pressure trip with the corresponding increase with the speed setting. Servo oil pressure. Engine lube oil pressure will be required with the initiating shutdown increase when the shutdown plunger moves sufficiently in the trip the alarm switch. In addition, with the oil trap with the governor speed, but saying the servo position flows with a smaller diameter on the left hand of the end of the shutdown plunger drains the sump. The action allows the speed setting servo spring to raise the speed setting of the servo's position. When the piston moves up sufficiently, the piston rod lifts, and the shutdown nut rods, the shutting of the shutdown rods will lift the governing pilot valve plunger, which lifts the above the center piston with the oil trap below. The power piston drains the sump. The power piston moves to the full position off position. Alright, important. The shorter shutdown plunger must be pushed back to restart the engine except for the modulating governors. Adjustment of the spring seat in the field is not recommended. Adjustment of the bias for low oil pressure required with the shutdown. Adjust the spring seat on the testing stand during the testing after an overhaul. No further adjustment should be necessary. Water pressure shutdown alarm. A water box engine with the water pressure to shut down the engine when the water pressure is too low. The device operates with low oil shutdown device described above. The exact with the low water pressure indicates the shutdown engine. Bypass valve. The governor pressure oil is supplied with the shutdown piston with one of the two ways, depending on the speed setting. The rate speed setting with the bypass valve to move down with the seat with the speed changing mechanism. The governor pressure oil pressure passes directly to the shutdown piston, with immediately initiates the engine shutdown to evaluate event of the lube oil failure. Our figure 3-4 shows the lube oil pressure shutdown and alarm. The governor pressure is the darker oil. The intermediate pressure shows the lighter shade of the gray speed setting servo, and the darker and lube oil pressure. Starting on this side, the governor oil pressure diaphragm, lube oil pressure diaphragm, the adjustable spring, load spring, and engine lube oil pressure. While you move on to the shutting down of the plunger and the shutdown piston, alarm switch, shutting down plunger, speed changing mechanism with its bypass valve, adjustment sleeve with the speed piloting valve, bushing, timing delay pointer to increase or decrease timing. And then the shutdown nuts, shutdown rod, piston rods, servo setting, servo pistons, speed setting, servo springs, speeder spring, governor pilot valve, plunger, and over here you have a power piston. Alright, when starting the idle speed, the bypass valve is closed with the governor pressure oil travel to the intermediate flow, or if it's rotating speed, setting off the valve with the bushing, while each of the rotating the bushing, a slot with the bushing register for the oil supply passage to the governor column to the oil hole, and the adjustment sleeve with the intermittent pressure oil vast. The shutdown valve plunger, the adjustment sleeve may be turned and reducing the time of the delay pointer of the cross-sectional area of the oil patch to increase the volume of the oil supply of each of the rotation of the bushing, increasing the decrease, turning the pointer with a clockwise increase of the volume, and decrease of the time required to pass sufficient oil to the initiate shutdown. Alright, your fuel limiter. General, the fuel limiter is an auxiliary system designed primarily for the use of the Woodward PG load governor installed with the low turbocharged, supercharged locomotive engines. It is used with the manifold air pressure for the reference. The governor is equipped with the load control overriding solenoid provision of the fast unloading. The function of the load control independent with the fuel limiter, with related with only for the optional reference of the manifold air pressure. The figure 3.6a illustrates the back fuel limited with load control override with the bias linkages installed with the locomotive of the governor equipped with the load control overloading solenoid and solenoid speed setting. During acceleration, supercharged engine, it is possible to supply more than the fuel engine that can be burned with the available air. The result from the normal lag of the supercharger speed, the consequently manifold air pressure decreases the respect of the engine speed. The fuel limiter restricts the movement of the governor power piston toward the increase of the fuel direction, limiting engine fuel during acceleration function as a manifold air pressure approximation of the weight of the air available. Adding instance, the full limiting improves the fuel to air ratio during the acceleration, allows the complete combustion, and improves the acceleration, reduces smoke. Fuel limiting also protects the engine if the turbocharger fails to reduction in the engine air supply occur. Figure 3.5 shows illustrates the unlimited steady state for the fuel schedules for a typical engine together with a typical acceleration transition from one steady state condition to another. Our figure 3.5 shows the typical acceleration of fuel schedules curve. The power piston travel fuel with a manifold air pressure maximum and maximum. Steady fuel schedule, limited acceleration fuel schedule over the time, and the acceleration transit possible acceleration fuel schedule. Alright, description. The fuel limiter of the figure 3.6a is essential for the floating lever of the bell crank, pressure of the sensor for the cam, the hydraulic amplifier together with the feedback lever of the fuel limiting lever. The right end of the fuel floating lever to be connected with the tail rod with the governor power piston with the pivots with about one length of the bell crank of the left end of the floating level rest on the right hand of the hydraulic amplifier field back lever the position of the bell crank, thereby for the position of the floating lever pivoting pin with the determinant of the position of the fuel limited cam, the raising sensing of the floating lever of the pivot manifold. Air pressure increase allowed for the governor or to descend upward to the proportional greater distance between the fuel limit occurs. The pressure sensor for the force balance device consisting of the inlet check valve, the orifice pack for resistance, restriction piston cam, and assembly, the restoring spring of the bleed valve, the other gauge pressure, and the absolute pressure of below bellows arrangement. The sensor establishes the corresponding piston to the cam position for different manifold air pressure with the relationship between the manifold air pressure of the governor power piston with the fuel flow with the limiting occurs determined with the profile angular tilt of the cam profiles. Each are either linear or nonlinear depending on the engine turbo start supercharged characteristic hydraulic amplifiers. Pilot operated with a single action hydraulic cylinder. The amplifier provides with the force necessary to overspeed the resistance of the speed spring of the shutdown rod of the re-center of the governor pilot valve with the plunger when the fuel limit is reached for the given manifold air pressure. Operation: pressured oil enters the fuel limiter through the inlet check valve. The oil is directed to the upper side of the sensor piston through the orifice packing. A restriction on the underside of the sensor piston, the inlet check valve, that prevents the siphoning of the oil from a limiter of the housing during the ship down. With the period of the oil emits the time and the lag with the refill the orifice of the piston cylinder prevents the sensor for the piston with the going maximum fuel piston during the start of the bleed valve regulates the rate of the oil flow under the sensor piston. The sump is a function of the manifold air pressure of the bleed valve that passes by the greater flow of the oil from the area than is emitted with the orifice back. The sensor piston moves the downward conversing of the reducing the pipe bypass oil with the less than emitted with the causing the sensor piston with the inflow with the outflow with the oil equal to the piston remaining stationary. Sensing element: absolute pressure for the typical fuel limiter consists of the two opposed flexible metallic bellows with equal effective area. The upper bellows evacuated the lower bellow sense manifold air pressure. The spacer of the joins the bellows the center wall. The outer end of each of the bellows is restrained to prevent movement of the manifold air pressure, actually acting internally on the sensing bellows, producing the force causing the spacer to move toward the evacuated bellows. Evacuated bellows provided with the absolute reference, therefore, is sensing the bellows directional portion of the absolute manifold air pressure. The movement of the bellow space for the transmitted through the output strap and the bleed valve of the pin of the bleed valve diaphragm. The sensing element of the gauge pressure type of the fuel limiter consists of a single flexible metallic blows. The move of the gauge pressure bellows is transmitted directly in the bleed valve pin. The bellow force of 10 to open the bleed valve while restoring the spring force to 10 with the close of the valve. Alright, your governor oil pressure, the dark, then trapped oil, and then governor sump oil with the governor intermittent oil pressure. Starting from the top, we're going to go to the overriding option, the overriding lever, optional load spring, fuel nut, fuel limit nut, the yield string, fuel limit lever, shutting down bushing, shutdown rod, feedback lever, piston valve plunger, hydraulic amplifier. Limited adjustment, load control, overriding solenoid, overriding adjustment, fuel floating limiter, floating lever, bell crank, flower, anti-siphon check valve, sensor piston, restoring piston, bled valve with diaphragm, centric adjustment, adjustable seat, bleed valve pin, evacuated bellows, sump, pressure sensor, eccentric adjustment, output strap, sensing bellows, manifold air pressure, tail rod. Of that overriding piston sump and the sump of the max excitation, vane servo meter with a minimum excitation, max fuel, load control pilot valve, sump overloading, load control overloading solenoid, governor pilot valve plunger. 36A is a schematic drawing of the fuel limiter linkage. When these opposing forces balance the bleed valve of the diaphragm flow with just off the seat of the bypassing of the oil sump, the rate of the oil flow maintains the constant flow of the oil area under the sensor position. Assuming the governor speed setting of the advance for the higher speed setting of the highly manifold air pressure, the governor power piston moves upward as supplying the additional fuel required for the engine's acceleration. Since manifold air pressure lags the engine's acceleration, the fuel limiter bell crank initially remains stationary under the manifold air pressure rises. Alright, as the governor power piston moves upward with increase the fuel floating lever piston pivots about the upper level with the bell crank depressed with the right end of the feedback lever on the hydraulic amplifier, pushes the amplifier pilot with the valve with the plunger below the center, allows the pressure of the oil to flow into the air under the amplifier piston, causing the piston to rise. As the piston rises, it simultaneously lifts the left end of both of the fuel limiter level and the feedback lever. When the fuel limiter level contacts the fuel limit nut, the shutdowning of the bushing begins with the limited shutdown route of the re-enter center of the governing pilot, but the plunger of the upward movement of the fuel limit and feedback levers continue until the left end of the plunger lever rises far enough to recenter the amplifier pilot valve plunger to stop the flow of the oil to the amplifier piston. At this point, the fuel center of the re-center of the governing pivot valve with the plunger stopping the upward movement of the governing power piston limits the amount of fuel to provide with the proper fuel-air ratio efficient burning, although the governor flyways at any of the underspeed conditions at any time the power piston remains stationary until the manifold air pressure rises. As the engine speed and the load increase, the manifold air pressure rises with a short time, and the load lag. The increase of the manifold air pressure produces the proportional increase of the sensing bellow force. The bellow force is now greater than the restoring spring force, the cause of the bleed valve of the diaphragm to move forward. They're off the seat. This allows the greater flow of the oil sump to be emitted through the orifice pack of the governor oil pressure acting on the upper side of the censoring piston force of the piston up and cam downward and processing, further compressing and restoring the spring. Piston continues downward movement, and that increase the restoring the spring and the force is equal to the net increase below the force that restores the bellow and bleed valve diaphragm in the original position at the point of the outlet flow, again equal to the inflow. The position stop moving. At the sensor position, as the sensor piston can move downward in response to the rise of the manifold air pressure, the bell crank rotates clockwise, and this allows the floating lever to pivot and left end of the lever to turn and hydraulic amplifier pilot valve plunger to rise. Loading spring under the pilot valve plunger maintains the positive contact between the plunger and the lever of the bell crank at the cam. When the pilot valve plunger raises above the center of the oil under the amplifier piston bleeds to the sump through the drilled passage for the center plunger. The passage of the plunger restricts the rate of the oil flow to the sump, decreases the rate of the flow from the amplifier piston. The moving minimize hunting. The amplifier piston moves downward. The left end of the fuel limit lever also moves downward. Lowers the shutdown rod and turns the lower governor pilot valve plunger, increase the engine fuel. The above events continuously rapid sequence normal governor operation overriding during the acceleration transition. Engine speed or engine fuel is scheduled to function in the manifold air pressure regardless of the governing speed setting to prevent the interface with non-normal governing action during the steady state with the operation of the sensor piston and continue for their downward movement until they're sufficiently below the effective limiting point. Conversely, a drop manifold air pressure rotates with the bell crank counterclockwise to lower the fuel limit, depressing the pilot valve plunger, releasing the pressure or oil of the underside of the amplifier piston, shutting down the rod of the governing pilot valve plunger as rate, releasing the oil to the power piston, accelerator to something to increase the fuel, to increase the left end of the fuel limiting flow leveler pilot pivots upward and releasing the hydraulic amplifier pilot valve of the plunger upward as the control end of the pilot valve plunger opens the port of the piston cylinder. The oil the bed to sump the hole in the pilot valve plunger. The shutdown of the rod is lowered and allowing the governing pilot valve of the plunger to recenter. Load control override linkage. Load control override linkage consists of the overriding lever which connects to the left end of the fuel limiting lever of the load control overriding cylinder, which and the pin in the yield spring. Combination of the overriding solenoid and adjusted the set screw must be adjusted with the fuel to depress overriding solenoid plunger completely at the point of just before the fuel limiting contacts the fuel limiting nut. The pressure oil pressurized underside of the overriding piston, lifting of the load control pilot valve with the plunger to decreasing the load direction during the acceleration transit. When the fuel limiting occurs, the integral vein of the servo motor brings the unload of the prior acceleration to lag, reducing the overload and the poor acceleration depending on the engine and turbo supercharger. The characteristic premature unloading can permit engine to accelerate quickly and raise the manifold air pressure rapidly enough to prevent any fuel from limiting through the taking place. Alright, on the governor application, important. On the governor application, load of the engine is adjusted through the servo motor operated with the rheostat field excitation circuit with the generated servo meter. In turn, is controlled through the governor load control system. As engine speed near the new setting of the manifold, air pressure rises with the downward movement of the fuel limit lever permits for the overriding solenoid plunger to rise. Oil is released with under load control over the piston with some lower to the load control and pilot valve with the plunger. Load control pilot valve with the plunger moves down, releasing the pressure oil to the servo meter. This increases the excitation, increase the load with the portion, increase the engine speed. The LVDT, or the Linear Variable Differential Transformer Load Control System. Second person of the governor to maintain the different horsepower output of the engine specifies the speed setting of the governor to achieve the objective of the LVDT, or Linear Variable Differential Transformer, just through external circuitry, the generator of field excitation current to keep up with the traction motor load set point. The linear variable differential transformer provided with linear output voltage over the different displacement measuring range of 1 inch. It consists of the primary coil of 2 separate secondary windings, enable the copper wire with a common cylindrical resin bonded glass fiber core with a ferromagnetic stainless steel case for the housing of the oil coil. Housing the coil or assembly provided with the fuel electromagnetic electrical static shielding. All internal voids are filled with the epoxy resin. The spring-loaded captive cores is manufactured from the nickel and the iron alloy, move freely in its guide. This device requires excitation of 6 VAC or RMS at 2.5 kilohertz. The device's resolution of 25 MVs per 1/1000th of an inch displacement. The excitation voltage is applied with the primary winding, 2 secondary windings opposite side of the direction, each with the movable core. The center of the secondary voltages are equal to the amplitude of the opposite phase. The other core position of the secondary voltage will be still and be opposite with the phase no longer equal to the amplitude. But the amount of the amplitude difference is proportional with the distance of the core's center. The rectifier assembly connected with the secondary windings of the limited linear variable differential transformer converts secondary AC voltage to DC voltage amplitude, with the DC voltage proportional to the core distance from the center and the polarity of the DC and decay with the core direction from the center. Rectified DC voltage has a resolution of 10 millivolts per inch. The linear variable differential transformer core center position depends on the governing speed setting of the core position. Plunger will sensing engine with the load governor speed setting of the change of the engine load. The horsepower moved to the core for the center position. When the engine load increases, the linear variable differential transformer cord moves toward the decrease in the generator excitation voltage. Decrease the load. Since the load is reduced, the governor would decrease the fuel. At the same time, the linear variable differential transformer core position continues the engine speed that is called by the governor speed setting with the linear variable differential transformer core is once again centered. The horsepower is now at the design value with the present speed setting. The governor has responded to the increased load without long-term change in speed. When the engine's load decreases, with the response similar in both directions. Alright, your starter fuel limiter. The starter fuel limiter minimizes the tendency engine, but the flood of the starting minimizes the excessive smoking during the engine cranking. The starting of the fuel limiter consists of the fuel limiter level with the adjusting limiting screw and a lever spring. Figure 3.6b shows the limiter linkage arrangement. The limiter limit lever extends with the floating lever between the speeding sensing servo piston, power piston, tail rod. The tail rod piston position, a function of the fuel setting. The speed setting of the servo piston is a function speed setting. When the tailored movement moves up the fuel, increases sufficient power of the floating lever. The free end of the fuel limiting lever spring continually urges the limit lever down with the direction of the contact of the floating lever. The adjusting limiting screw attached to the lug in the fuel limiter with the head of the screw fits under the shutdown. The limiting of the screw adjusting the shutdown nuts and shutdown rod is lifted with the tail rod reaches the point with the corresponding desired maximum starting point. Lifting the shutdowns and the shutdown nuts and rods prevents the governor from increasing fuel further. Alright, whenever the governor speed and setting is increased, the speed setting of the servo piston moves downward. The action moves the floating the rod lever down away from the fuel limiting lever so that its limit no longer restricts. Alright, starting from the left, going from the left to right, the power piston tail rod, the floating lever, the fuel limiting lever, adjusting limiting screw, the lock nut, the shutdown rods, the nuts, and lever springs. The Figure 3.6 shows the starting fuel limiter linkage. Chapter 4, Troubleshooting.